around. All right, geometry review for chapter 4. I'll tell you which ones we're going over. If you have any questions, you may ask, of course. This would be our first problem, and definitely this first whole page is definitely going to be on the quiz. You need to know what this means. What are the lengths of the sides of this equilateral triangle? What's equilateral mean? Yeah, all equal sides. All sides equal. All right, so let's pick the easiest ones to set equal to one another. We don't want to set them all equal to each other, because what would we solve then? You know, it doesn't, we just need a pair. So the easiest pair would be, go for these two, right? So let's do 4x equals 3x plus 5. We know how to do the algebra. We've been doing it all year. We subtract 3x from both sides. And we got x is 5. Okay, now it said to find what are the lengths of the sides of this triangle. Well, we're going to have to plug 5 back in. No matter where we plug it in, we should get the same answer because it's equilateral. So we do 4 times 5 and we find out one side is 20. Yep, check this one out. We do 3 times 5 plus 5, which is 15, and 5, which is another 20. So all 3 sides are 20. But it's kind of good to double check that you plugged in more than once. That's because then if you did get a different answer, you'd know you probably did something wrong in your algebra. Okay, number 2. What is the measure of angle 1? In your ISN, I believe it is on page 2. There is by page 1, I think we had triangle angle sum theorem, right? Where we ripped a little triangle and some of us taped it in there. Okay. Then we had this exterior angle theorem. Okay. So on page 2 of the ISN, it says that if you have an exterior angle, then it's equal to the sum of its remote interior angles. So that would say for this diagram that these two angles added, the measure of angle 1 plus 90 is 120, equal to the exterior angle. And then we can subtract 90 from both sides. Now, I've got some pretty bright people around, and I want to know if anybody got that answer before I said this, but did a different way. Some people may have done that. Did anybody think of a different way? Or maybe we'll just already discuss it. All right, go ahead. Okay, that's what I was looking for. There is a different way to get this answer, but I need you to know the way I just did it, because what if there were different answers, like X's and stuff on here? Then you'd need to know, say if this was an expression and that was an expression, you'd need to know the property that I'm discussing. But there's another way to get it for this problem, and what Murphy just said was he noticed these are a linear pair, right here, right? And that this one would be 60. Then he could have done 180 minus 90 minus 60, and this one would be 30. Does that make some sense to you? I hope. Because we kind of need that number. Well, if that's 120, what's this angle right next to it also? Yeah, there's a straight line. So let's use that linear pair idea. So those are 60, and it makes sense that these are 60 because they're vertical. Okay. And then there's one little thing about here that we talked about isosceles triangles, but we're going to actually fill in that ISN today about isosceles. Do you think there's enough? Well, if you got 2 equal sides, then there's got to be 2 equal what? 2 60s, yeah. Where else is there going to be a 60? Right over here, right? Okay. So then that means angle 2 is going to be 120, all right, because they are a linear pair. All right, so the measure of angle 2 is 120. So if a triangle has 3 equal angles, each of them is 60. If a triangle has 2 equal angles, then you can figure out the 2 of them are the same. Okay, thank you. All right, next one. Number 4. Wait, yeah, that was one. I've got a triangle congruent statement here. It says the triangle TGS is congruent to triangle KEL. And then it says which angle in triangle KEL corresponds to angle T. How do you know it's K? Same spot. Okay, every congruent statement tells you a wealth of information. Because T is the first letter, K is the first letter in the second one, T and K correspond. That means angle K is congruent to angle T. Now, with that in mind, what if I gave you what's congruent to EL? You would look over here and say EL middle last, it would be GS. Okay, so you can do segments too. So if you want to add that to this, and because we're studying, you can get any pair of things you want, including angles with 3 letters in them. You know how we name some angles with 3 different letters. And that's going to come up shortly. Okay, next though, we're going to graph a triangle with the following vertices. Let me slide that up a little bit. We've got A at -3, -1. So we've been plotting points a lot. Now that's left 3, down 1. B -2, 2. Be up here. And 3, 1. C. We're going to connect. Wait, my pen's drifting. And draw the triangle. And then it's asking us to classify by the sides. So it's based on the length of the sides. So we're going to practice finding the length of the sides right now. I will do it because it's in the coordinate plane. I want to do it by the Pythagorean theorem method, which is the same as is related to the distance formula. So I'm going to find side BA first, or AB. I don't care what you call it. I'll call it AB just because that's the order I'm going to do things. Okay, to find side A, the length of AB, I need to go and count from A to B. So I'm going to go up and over. I went over 1 and up 1, 2, 3. So I can do 1 squared plus 3 squared. The change in the x's is 1. The change in the y's is 3. If I'm just doing Pythagorean theorem, it doesn't matter if I do 3 squared plus 1 squared. So the order of this doesn't matter. But then I have to evaluate this. If I type on the calculator 1 squared plus 3 squared, you should get the square root of 10. Because this is 1 plus 9. You can do it without the calculator if you like. Now I'm going to find the length from B to C. So then I'm going to count from B to C. We've done this distance formula many, many times. And I'm going to go over from B and then down to C. And that's going to be 1, 2, 3, 4, 5 across and 1 down. I'm not worried about sign because I'm doing Pythagorean theorem. So 5 squared plus 1 squared. You can type 5 squared plus 1 squared, but then you need to write the square root of, that's 25 plus 1, so you should be getting square root of 26. Finally, I'm going to find the length of A to C. From A to C, I count over and up. I went over 1, 2, 3, 4, 5, 6. So I'll do 6 squared plus 2 squared. Oh, that's 36 plus 4, so I get the square root of 40. Oh, wait, none of them match. Okay, now we would have to remember our vocab. It said classify by the length of the sides. None of them are the same. That's that weird word. Isosceles is when 2 are the same. Scalene. I've heard a lot of people say scalene, and that's the correct one. This is a scalene triangle. The other weird word, I guess I shouldn't have said that because a lot of kids think of isosceles as being a strange word as well. Scalene and isosceles. I think a lot of people think a lot of my geometry vocabulary is weird words, but anyway. Moving to number 6. This one we get to classify. It's already drawn for us. We just have to look at it. It says classify by its angles. So is it, these are all the types it could be. Remember, right triangle has one right angle. Acute, all three are less than 90. Equiangular, that sure doesn't look equiangular, like they're all the same. And obtuse, I don't see a big fat angle on that one. Does it have a right angle? Nah, they're all little, aren't they? Oh, it's acute. All angles were less than 90. Okay, number 7. This one looks like they're all the same. All of these angles are equal. All of the sides are equal. You could use a ruler and tell if you wanted, but that's what it is. So if I want to classify it by angles and sides, it's equiangular. And these vocab words are in your ISN with pictures. No excuses to get this wrong. Okay, the sides are equal. That is equilateral for sides. I don't care which one you really wrote first or second, just as long as you have both of them. Equiangular and equilateral. Whenever you have a triangle with all three angles the same, it's got all three sides the same. And whenever you have a triangle with all three sides the same, all the angles have to be the same. No, you have to write, yes, okay. You have to write the whole word. How else would you write it? Like, what would you write, though? No, let's stop being that lazy. I let you abbreviate enough, so I think that I can get the whole word on these, please. Thank you. I really do let us abbreviate a lot. Thank you, though, for asking. All right. We got to find the angle measures. How many triangles do you see? I hope you see 2. Okay, we're going to use top triangle and the bottom triangle. And we're going to find angle 1 first. Okay, so all angles in a triangle add up to 180. Keep that in mind. We also have 2 angles that crisscross each other, which means we've got some angles that are, what are they called? Vertical. Okay, angle 1 is 47 then. Okay, now we're going to find the measure of angle 2 and the measure of angle 3. We will use the top triangle to find the measure of angle 3. Since we know the triangle angle sum theorem, that is on page 1 of your ISN, that these angles all add up to 180. So to find angle 2, let's take 180 and subtract the 2 angles that it already has inside the triangle, 59 and subtract 47. Okay, if you do that, that's 99, 106, it should be 74. All right, and then down here, to find angle 3, angle 3 will be found by taking 180 and subtracting from that 47 and 64. That's 111 to be 69. Okay, we're done with that one. Number 9. Okay, I like this question, and I asked it for ours. A few people got it. Before you blurt out, look at that picture and tell me how many triangles you see. Don't say it too fast. Okay, how many of you think it's 3 triangles? No one wants to raise their hand. Oh, I did one. 4 triangles. 5 triangles. Anybody go past 5? No, you can't go past 5. It is 5. Okay, and here's what, I know what your eye's wanting to do. You're wanting to just see this little one, and this little one. But then you got this big one right there. Okay. And you got this big one over here. So there's 1, 2, 3, 4, 5. Now, do you have to know that to do the problem? You probably don't have to. So let's see what we can do. I just thought it's interesting for your eye to try to notice how many there actually are. Okay, so I'm going to go ahead and separate them up. Let's find angle 1 first, and it would be found by doing this little triangle here. Okay, so go for it. Calculate your angle 1, please. The sum of the 3 angles by your triangle angle sum theorem is 180. Okay, now I think it's 77. Thank you. Now let's go ahead and put that on the picture because that could help us out. Or you could find angle 2 if you put the green and the pink one together. Because you could take 180 minus 41 minus 37 minus 66, and then you'd get angle 2. If you don't do that, then you have to remember about linear pairs. You see angle 1 is 77. What's the angles next to it? What's that? 180 minus 66 minus 37. You guys just told me it was 77. Okay, this would be 103. Okay, which means the angle across from it, the vertical to it, is 103. Okay, you're going to have to use some thinking like this tomorrow. The measure of angle 2, well, let's just use the top green triangle here. Okay, and then when we're go get angle 3 by using this triangle over here. All right, so why don't you find those 2 answers, please? All right, somebody want to tell me what they got that's not always answering questions? Not that that's a bad thing, but I know who's going to answer. Bryce? 36, is that what we got? Okay. And how did we get it? Was 180 minus 103 and minus 41. Okay, and you got 36. Thank you. Good. All right, go find angle 3. Everybody should be able to do that one. You got that one already? Bryce is on the ball today. He's ready to go. He's already finished angle 3. I bet there's somebody else who's got angle 3. Like, something. I see you look like you're holding something and your eyes closed. Yes, you can. Well, that's nice to help her out. I was hoping you knew what the angle was, but you know what? I could see what was happening. So, all right. Leanna, I always do that to myself. I got to remember it's Leanne. We got 30. You guys getting 30? Okay, that is correct. Thank you. I always got to sorry about that, Leanna. I always want to add an L in there. Okay, 10. Ooh. 10 is kind of a pain in that it's a multiple choice question. It would be a lot nicer for me to be able to just not do a multiple choice for this, and I would start off with giving you the beginning triangle and then you fill in the second part. No, it's not, but I just guess going through them one at a time, most kids find tedious. You did find it already? All right, let's see what's going on. It's got to match up right. So if you went K to L to J, KL is the long side with a single slash. You would have to do NL, and it doesn't start with NL. Okay, do you see what I'm saying? Please look at what I'm talking about so you understand this. Because if you get a question like this, you have to figure out which one it is. KL would be going from here to here. It should say NL, and it doesn't start with NL, so it's definitely not A. Okay, JLK. J to L means you started with this point and you went to L. You need to go from M to L. Does this even start with ML? No, so it's not B. The next one starts with JK. J to K. That's the side with 3 marks on it. You would have to be going from M to N, and this doesn't start with MN. So that's knocked out. So it better be D. JKL. J to K. To do M to N? Yes. So MNL would be correct. It's D. I can tell that everybody has to turn their paper now. I hear paper turning. We are doing 11. All right. 11 is part of what might be on the quiz tomorrow for sure. Triangle FGH is equilateral. That meant that all sides are the same. All equal sides. So that means we can set these two sides congruent to one another and solve for x. So we got 3x minus 8 equals 2x minus 1. Solve it? All better? So we got x minus 8 equals negative 1. All right, you got 7, then you solve correctly. Did anybody figure out yet what to do to find the y value? Now we're not talking about sides. That arrow's pointing at angle H. How do I know what to do if they didn't put any numbers on here? All sides equal and all. All right, if all the angles are equal, how big is each one? I heard you say it louder, please. 60, Kenny, yep. They're all 60. So, Donovan? Plug in all of the sides are 13. That's correct. Yes, all of the sides are 13. It didn't ask me to find the length of the sides, so I wasn't even going there, but you could be asked that for sure on the quiz tomorrow. I'm trying to find out what y is now. So what I was saying was these angles have to be 60, so we're going to need to do a new equation now to find y. Well, I'm not going to start off with 60. I'm going to say 4y minus 4 is equal to 60 degrees. Okay, now you should be able to solve for your y. But you're right, Donovan, each side is 13. Add 4, you get 64. Divide by 4, you should be getting, all right, everybody getting 16? Any more questions about that problem? All right. And each side would have been 13. Number 12. This is what I meant by knowing that external angle theorem. If these had some variables on them, you want to know that when you add these two, it equals the exterior angle. So 8x minus 30 is equal to 50 plus 70. So 8x minus 30 equals 120. Find x. Okay, so I hope you're all calculating what x is right now, because I want you to know that it's okay if it's not a whole number, but it's a decimal. You should be getting a decimal. Let's see if we got the correct decimal. Evan, what'd you get? What do you think you did? Did you subtract instead of add? Okay, so did you do 90 minus divided by 80? Okay, you see what, all right. If you did 90 divided by 80, then you're made a little boo-boo by subtracting 30 from 120 instead of adding, okay? All right, should be 150 divided by 8. That's correct, Akasha. 18.75. That's it. Yep, it's 18.75. You want to give me the whole answer. It's like 18 3/4. Don't round it. Just write 18.75. Anybody have a question on that then now? All right. We got to keep going. I'm going a little slow today. Find X and AB and BC and AC if it's an isosceles triangle. Isosceles triangle, and it tells you that AB is congruent to BC. You got to read everything so you know what to do. Segment AB is congruent to segment BC. We're going to set those sides equal. 5x plus 5 equals 2x plus 20. And then I solve and I subtract 2x. Oh, and then I subtract 5. 3x equals 15, and then I divide by 3. You should be getting 5. Okay, kind of need to make sure I get through every question I want to. So it's asking us to now write an equation for our work, and it asks us to find the length of the sides. So how big is, we've got x, now we're going to find AB, which would be 5 times 5 plus 5. That's 25 plus 5, and it's 30. B to C should be 30. 2 times 5 plus 20 is 30. But A to C is going to be different. Yeah, 9 times 5 minus 5 would be 40. Okay, we needed all 4 answers. Anybody still need 13? Okay, 14 we are skipping. We're going to save that for before the next quiz. Correct. If you might know how to do it, but I haven't really explained or done the section yet. We're going to be doing 4.6 on Monday, and it'll be a lot of problems with these kind of pictures. Okay, we're not going to do 18 through 21 yet. This is on quiz 2. This will be quiz 2, chapter 4. Okay, but we should do 22. All right, we've got a congruent statement. We've got some things we need to find. I see that we've got a side with 2y minus x on it, and it's on side EF. So I look up here and I see FEF is corresponding to BC. So that means 2y plus x equals 38.4. Well, how am I going to solve that? I got too many letters. I can't solve it right now. So let's check out what else is available on the picture. We've got 8y minus 5 on angle F, and angle F corresponds to angle B. So since angle F is equal, measure of angle F, or they are equal, angle E, F equals angle B, I'm going to plug in 8y minus 5 for angle F. And then I'm going to go up to angle B and say, okay, it's 99. Plug that in. So now I can solve for y. I'm going to add 5. 8y equals 104, yep. And then I got to divide by 8. Let's hope that goes nicely. I believe it does. What is it? 13. Perfect. Okay, let's go plug in that 13 up here now. 2 times 13 plus x is 38.4. That's 26 plus x equals 38.4. And now we easily can find x by subtracting 26. And that gives me, yeah, 12.4. Okay, are we good with that one? Anybody still need it? Okay. Complete the following congruent statements by naming the corresponding sides or angles. All right, this should be a cinch for us. What corresponds to segment AB? There you go, AX, whoopie-doo, right there in the statement. Now let's see if we can do this one, because it's an angle with 3 letters. It goes C to B and then to T. So that would be A to D to Y. Yep, angle ADY. Any questions about that? Just follow the letters, jump around the letters the same way. Okay, now we're going to have some questions where we got to figure out what it is. So let's write down the postulates that we've used. Side, side, side. Side, angle, side. Somebody give me another one. Angle, angle, side, okay? Angle, side, angle. Okay, there's been one more. HL. Yep, that was yesterday. Hypotenuse leg. CPCTC is going to be used after we use one of those, so that's not going to be part of any of this. All right? CPCTC is corresponding parts of congruent triangles are congruent. Once you prove triangles are congruent by one of these, then you can use it to tell me other parts are congruent. All right? All right. What you do want to do is quickly mark shared sides congruent in the picture or vertical angles. Okay, so then I look at this and I see arc marks on these corners, which are angles. Okay, you got an angle and an angle. In here, you've got a side, and then here you've got an angle and an angle. All right, now, this one's a little bit tricky to look at. Is this angle, side, angle, or angle, angle, side? Is this side smushed between the two angles, guys? This one's a little tricky by how, okay, so maybe we don't want to write these letters on here. Maybe you're going to see it better. Let me show you what I mean. So I'm thinking that those letters actually made it more confusing. Because now, if you put them out here, do you see how it's two angles and this is a not between them? That's AAS. That's why sometimes I don't like writing the letters on there. All right, so if you understood it now without the letters on there, because this is not between those angles, okay, then it's AAS. All right, this one, shared side in the middle. This one's the easy one. All of those are what? Yes, side, side, side. There was a chorus. I hope that showed on my recording. All right, we've got shared side in the middle. Two sides is the angle between. SAS. All right. Uh-oh. We got a problem. None. Can't do it. Not possible. Doesn't even matter about the shared side. Because these things aren't equal. Right? These two are equal to each other. It's just all that means is that's isosceles and that's isosceles. And this could be, it could be something like that attached to something like that. There's no proof that, okay, there's no proof that those were equal, even though they look like it. All right. Now, this is going to be a question. This will, on the test tomorrow or quiz tomorrow, it is sort of like a test. You're going to take the whole period with it. You're coming with your ISN prepared. This is extra credit type of question. I think you can do it, but it's going to be extra points. So you have an opportunity of getting over 100% tomorrow or helping your grade if you can do some of these. Now, here's what they're asking. They want us to use SAS. Now, automatically, no matter what you guys are working on, if there's a shared side or vertical angles, you want to mark it. Okay, bam. So just like in this one, I want to mark that. All right, now, what they're asking us is, where would the angles need to be for us to be able to do SAS on this diagram? It has to be where? Between the sides. So where is that in this picture so we can name those angles? You got to go look at the picture and say, well, would it be over here? No. Is that between these two things? So it's got to be up here, right? See what I'm saying? We would want that angle to be congruent to the one down here. All right, so we got to name them. It'd be angle, let's try K, J, I. Would need to be congruent. Angle, now hold on, K, J, I. I will want to say P, I, J. Did I? P, I, J. Yeah, I've got to be down here, right? I has to be in the middle. Up here, J has to be in the middle of my letters, okay? All right, this one, we want side, side, side. Oh, gosh, if you have one you can do like that, that would be pretty easy one for you to get extra credit on, right? All right, all you need is the pair of side that's not marked. You need these. And that would be SL, or I don't care if you do LS, SL congruent to KL, or reverse the letters is fine. All right, you need the other third pair of sides congruent. Any questions about that so far? You fixed it? Okay. All right, last one. State additional information needed to state the triangles are congruent. Okay, I've got a side in the middle. They want us to do angle, then a side, then an angle. We've got it. No, we got to look at the two triangles separately, guys. Okay, so I've got to look at this one versus the other one. Okay, so I need to figure out where to put them that angle. Then, so it'll be ASA. So I want the side in between that angle right there. I got an angle, then a side. What would I need on this top triangle? It'd have to be down here. You see how it couldn't be up here? That would be an angle, then a side. So down here, I need that congruent. And then if I go over to the other triangle, it would be right next to it. Okay, angle, then a side, then an angle. All right, so this would be angle LFT. And if you reverse these letters, that's totally fine as long as F's in the middle. And angle, what is that going to be? HFT or GFH would be the same angle. I really had wanted to do the isosceles triangles in the ISN, but we could actually wait until Monday. I don't think it's going to hurt anything if we don't. So please study tonight your ISN and your packet that we just went over so you're prepared for tomorrow's quiz.